Hello friends, in this session you will learn the method to find the angle between two straight lines. In this session you will also learn what are the different forms of the straight lines. Let us start the chapter. There are two sets of intersecting line. In set 1, line AB and line CD are intersecting into acute angle and the obtuse angle. While in the second, two intersecting line AB and CD are intersecting in four right angles. Angle between two intersecting lines means we have to find whether it is acute angle or it is right angle between the lines. Now I am describing the method by which you can find the angle between two straight lines. Let AB line is making a θ1 angle with the x-axis anticlockwise and its slope is m1. Therefore, m1 is equal to tan θ1. Similarly, if line CD is making an angle of θ2 with the x-axis anticlockwise and its slope is m2, therefore m2 is equal to tan θ2. If the theta is the angle between the two lines, therefore by geometry θ1 is equal to theta plus θ2. Therefore theta is equal to θ1 minus θ2. Now therefore tan theta is equal to tan theta minus θ2, and by trigonometry tan θ1 minus θ2 is equal to tan θ1 minus tan θ2 upon 1 plus tan θ1 into tan θ2. Now putting the value of tan θ1 and tan θ2 as m1 and f2, therefore its value is m1 minus m2 upon 1 plus m1 m2. But angle of intersection means the acute angle between the lines, and if angle is acute angle, tan theta is positive, and angle is obtuse angle, then tan theta is negative. Since we have to find the acute angle between the line, therefore we will take the modulus of this formula. That is, the angle of intersection is theta, then tan theta will equal to modulus of m1 minus m2 upon 1 plus m1 m2. Now we take an example. If two lines make an angle 60 degree and 30 degree anticlockwise with axis, then find the angle of intersection. Here m1 is equal to tan 60, that is root 3, and m2 is equal to tan 30, that is 1 upon root 3. Since tan theta, if theta is the angle of intersection, then tan theta is equal to modulus of m1 minus m2 upon 1 plus m2, that is equal to modulus of m1 is root 3 minus 1 upon root 3 upon 1 plus root 3 into 1 upon root 3. Therefore, it is equal to, that is modulus of 3 minus 1 upon root 3 divided by 1 plus 1. That is modulus of 2 upon root 3 upon 2, that is equal to 1 upon root 3. Therefore, theta is equal to 30 degree or pi by 6. Therefore, angle between these two lines is 30 degree or pi by 6. Now we take the second example. If two lines makes the angle of 60 degree and 120 degree anticlockwise with x-axis, find the angle of intersection. In this case, M1 is equal to tan 60, that is root 3. M2 is equal to tan 120 degree, that is tan 180 degree minus 60 degree, that is minus tan 60 degree, that is minus root 3. Therefore, if the angle of intersection is theta, therefore tan theta is equal to m1 minus m2 upon 1 plus m1 m2, that is root 3 minus root 3 upon 1 plus root 3 into minus root 3, that is equal to root 3 plus root 3 upon 1 minus 3, that is 2 root 3 upon minus 2, that is minus root 3, and this is equal to root 3. Therefore, theta is equal to 60 degree, that is, or it is pi by 3. Now, there are different methods by which equation of a straight line can be represented. First method is slope intersect form. In this form, the equation is like y is equal to mx plus c, where is mx is slope of the line and c is the y-intercept. Suppose in this case, this line AB is the line, and in this angle making theta angle with the x-axis anticlockwise. Therefore, in this case, m is equal to tan theta. And if theta is the y-intercept, that it is making a distance of y, intercept of y on the y-axis, therefore its equation will be y is equal to mx plus c. Now we take an example. Suppose if a line AB makes the angle 45 degree anticlockwise is x-axis and y-intercept is 2, then in this case slope is equal to m is equal to tan 45 degree, that is equal to 1. And c in this case is y-intercept is 2, therefore c is equal to 2. Therefore, in this case, equation of line will be y is equal to m is 1. Therefore, it is 1 into x plus 2. That is y is equal to that is y is equal to x plus 2. This equation of this line can be represented as y is equal to x plus 2. Now, suppose equation of line is root 3x plus y plus 4, and we have to find the slope of the line as well as the y-intercept. Therefore, in this case, y can be represented as minus root 3x minus 4. Therefore, in this case implies that in this case slope m is equal to minus root 3. That is equal to minus tan 60 degree. And minus tan 60 degree can be represented as tan 180 degree minus 60 degree. Therefore, it is tan 120 degree. Therefore, this line AB makes an angle of 120 degree anti-clockwise, or we can say it is making 60 degree clockwise. Again, Since the equation of line is y is equal to minus root 3x minus 4, therefore this minus 4 is equal to c, that is c is equal to minus 4. It means line making a negative intercept of length 4. Therefore, the line can be drawn as this, which is making the 120 degree anti-clockwise with the x-axis and making a y-intercept as minus 4. Now we come to the second form of the straight line. Suppose a line AB is making a intercept on x-axis and B intercept on y-axis. Therefore, its equation can be represented as x upon A plus y upon B is equal to 1. Suppose there is an equation 3x minus 4y minus 12 is equal to 0 is an equation of a straight line, and we have to find the x-intercept and y-intercept which this line is making. In such cases, keep the constant always positive and brought the other variable on the other side. Therefore, this equation can be represented as 3x minus 4y is equal to 12. This constant should always be kept as positive. Now divide the whole equation by 12, then this equation is 3 upon 12x minus 4 upon 12y is equal to 1. Therefore, this can be written as x upon 4 minus y upon 3 is equal to 1. Implies that this equation can be written as x upon 4 plus y upon minus 3 is equal to 1. Therefore, it is clear that x-intercept is 4. That is, in this case, this x-intercept is 4. And y-intercept is minus 3. Y-intercept is minus 3. Therefore, equation can be drawn as AB, which is making minus 3 intercept on y-axis and 4 unit intercept on x-axis. Now we come to the third form, that is the normal form. Suppose AB is a straight line, and if we draw a perpendicular from origin to this straight line, that is OP is perpendicular on this straight line AB, and suppose this perpendicular is making an angle of alpha anti-clockwise with the x-axis and length of this perpendicular is P. Therefore, equation of this line AB can be represented as x cos alpha plus y sin alpha is equal to P. Now I am describing the method how you can convert equation of a straight line into the normal forms. Suppose equation of a line is ax plus by is equal to c, where c is positive. Always this constant should be kept positive. Now divide the whole equation by a square plus b square. Then this equation becomes a upon under root a square plus b square into x plus b upon under root a square plus b square into y is equal to c upon a square plus b square. Now put a upon a square plus b square as cos alpha and b upon a square plus b square as sin alpha, and c upon a square plus b square is equal to p. This equation will be in the form x cos alpha plus y sin alpha is equal to p, where p is equal to c upon a square plus b square. Now, since we know that a upon a square plus b square is equal to cos alpha and b upon a square plus b square equal to sin alpha, therefore we can find the value of alpha. Therefore, we can represent the equation ax plus by plus c in the form x cos alpha plus y sin alpha is equal to p. Now we take an example. Suppose equation of a line is under root 3x minus y plus 10 is equal to 0, and we have to find the normal form of this equation. Since we have to keep this constant as positive, therefore this equation can be represented as minus root 3x plus y is equal to 10. Now we have to divide the whole equation by under root minus root 3 square plus y constant of y that is 1 square, it is 3 plus 1 that is 2. Therefore, we are dividing the whole equation by 2. Therefore, equation will be of the form minus root 3 upon 2x plus 1 upon 2 y is equal to 10 upon 2. That is implies that it is minus root 3 upon 2x plus 1 upon 2 y is equal to 5. Now assume minus root 3 by 2 as cos alpha and 1 upon 2 as sin alpha. Since cos alpha is minus root 3 upon 2, therefore it will equal to minus cos 30 degree. Since cos is negative always in second quadrant or in third quadrant, therefore it can be represented as cos 180 degree minus 30 degree, or it will equal to cos 180 degree plus 30 degree. Therefore, it will equal to cos 150 degree or cos 210 degree. Therefore, in this case, alpha can be 150 degree or 210 degree. Similarly, sin alpha is equal to 1 by 2. It can be represented as sin 30 degree. Now it is positive since sin is positive in this case, it is possible only when angle is in first quadrant or second quadrant. Therefore, it can be represented as sin 30 degree or sin 180 degree minus 30 degree. That is equal to sin 30 degree or sin 150 degree. Therefore, in this case, alpha can be 30 degree or 150 degree. Therefore, by comparing these two, it is clear that alpha is either in this case, alpha can be 150 degree or 210 degree. In this, it is 30 degree or 150 degree. 150 is common in both the cases. Therefore, in this case, alpha is equal to 150 degree. Therefore, in this case, this equation can be represented as x cos 150 degree plus y sin 150 degree is equal to 5. Therefore, equation root 3x minus y plus 10 can be represented as this line AB and perpendicular from origin to this line is making an angle 150 degree anti-clockwise, and length of this perpendicular is 5. It is all for today. Now I request you to subscribe my channel so that you may get the notification regarding my upcoming videos. Thank you.